Terraform 1.8 and provider-defined functions. What are they? Why should we care? Who's this Bruno guy? What is happening here? Before we get into all that stuff, we've got some rituals to perform here.
Oh, okay.
Folks,
cool.
Get in on the conversation, or if you are in the live studio audience, we are listening, we are watching. The longtime listeners of vBrownBag know, they've watched the Python series, so they have a good feel for what functions are. They've watched the Terraform series, so they have a good feel for what providers are. So now we're going to marry those two concepts together and get into it. So with all of that excitement afoot, why don't we flip over to Bruno's screen? I'll shut up.
Cool. So Terraform 1.8, which we recently released, I think it's April 10 or April 11 that we released it, and it has a whole bunch of cool things as part of the release, including provider-defined functions. Like I said, something that I'm super excited about. It might sound a little bit abstract from just reading the title, but I'm going to try to make it a little bit more easier for you guys to understand how to use them, how to build them. So let's, I guess, kick things off with what are provider-defined functions. So I think the concept of functions is well known within Terraform. You have built-in functions, and we have a rich set of functions ranging from numeric to string to IP address related functions, but they're all built-in functions inside of Terraform core. And they aren't specific to any of our providers. They're very agnostic, right? So for example, you have a CIDR subnet function, or you have a floor function for operations on numbers. But there's nothing specific to AWS or Google or Kubernetes or any of the other providers plugins that we have. So what provider-defined functions are is everyone knows. So how Terraform operates, its product architecture is split into two distinct things. You have Terraform core, which is, as most people know, the Terraform CLI, and you can execute a plan and apply, you can init and do other things. But it doesn't have resources baked into Terraform core. Terraform actually uses plugins, so-called providers, to provide resources and data sources for Terraform to operate on. So you have an AWS provider, you have a Google provider. Google provider, for example, has a whole bunch of different Google resources. It is a Terraform plugin that wraps around the Google Cloud API. So you can create a bucket, or you can create a Cloud Run service, or a cloud. In AWS, you can, for instance, create an S3 bucket or a Lambda function. Because we have so many different providers, it makes sense to decouple them, right, and not have it in Terraform core. But it would also be pretty cool if you could have functions specific to a provider, and that's where provider-defined functions come in. So most people that have worked with Terraform know that providers only have resources and data sources. And since Terraform Core 1.8, so what the release we shipped 2 weeks ago, we're now also supporting functions to be part of a provider, and they can be similar to the building functions, things that you run offline and you use them to transform data. You give some input and you get either a value back, a computed value, or you get an object back if you want to do an operation. For example, if you floor something, or if you do a CIDR subnet where you provide a CIDR range and you want to split it up by prefix, you get back a list of different CIDR ranges. Now, with provider-defined functions, there's provider-specific transformations that we can do. For instance, AWS, I'm going to dive a little bit deeper in them on a moment, but for instance, AWS has an ARN build function now and an ARN parse function where you can construct an ARN from individual strings, or you can deconstruct an ARN into an object, and you can reference just the account ID or a region. And for the Kubernetes provider, we, for instance, have a way to encode a YAML manifest, Kubernetes YAML manifest, to Terraform HCL. So those are pretty cool things that we can now do operations, like functions on provider-specific things. So yeah, how would you go about using a provider function? Well, like I said, they are created as part of the provider, similar to a resource and a data source. So they are implemented in Go, much like the resource and data source as well, and they're built by whoever maintains the provider, and they have to be released as well before you can use it on the registry. Before you can use it in your Terraform configuration, you would pull them from the Terraform registry, for instance. And actually, before you can make use or before you can call a function in your Terraform configuration, you have to mark the provider as a required provider, because it's using the namespace, which is AWS in this case, whenever you're calling the provider defined function. So make sure if you want to call a provider defined function, make sure to mark the provider that exposes that function as a required provider in the required providers block, which is part of a Terraform block. That should be on the screen. Actually, how you call them, or like the signature of the function, looks like this. So value equals is optional if you want to do something with the value that's being returned. It's a syntax that is probably new to a lot of Terraformers. So it's provider, colon, AWS, the name of that marked provider that we have here, of the required provider that we have here, and then the name of the function that required provider exposes. In this case, this is an example, so I'm here putting in hello. That's the name of the function, and the argument is a string, and I'm putting in hello Mars. And this could, for instance, return the string hello Mars. This is just an example of how you define or what the signature of a provider-defined function is. Is that clear?
Familiar to AWS folks, but not necessarily familiar to Terraform folks.
Yes, yeah. So I'm sure some of the people that have worked with CloudFormation before would recognize this syntax. So it's new syntax to Terraformers. That's for sure. Mm-hmm. But maybe I can show you guys some example functions that we have in AWS, for instance. So we have the ARN parse function and the ARN build function within the Terraform AWS provider. So like I said, what I do is I declare the AWS provider as a required provider here in a Terraform block. And I specify the provider block itself as well for AWS because it needs it. Now, a good use case for ARN parse would be if you want to, for instance, extract the account ID. So what I do here is I create an ECR repository called HashiCorp, and I know from the top of my head that the AWS ECR repository exposes the ARN. So what I can do if I just want to output the account ID, I can call it this way. I hope it's visible, but let me zoom in a little bit. So if I want to output just the account ID of the ECR repository that I just created, I can do value. I declare an output block. I assign the output from this here to the value. So the provider, AWS, ARN parse, and then I put in the ARN that I reference the ARN from the AWS ECR repository. And that actually outputs an object. So if we would look at the Terraform registry, you can actually see the signature of the function, the arguments that go in there, and the attributes. And that would look like this. So if you go to ARN parse, this is on the Terraform registry documentation for the AWS provider. On the top, you have this functions section. And there we have ARN build and ARN parse. And I'm now, our example was about ARN parse. So you can actually see the result that it's going to give you here. So if you do ARN parse and you pass in an ARN, you get back an object that has the partition, the surface, the region, the account ID, and the resource. So it's basically deconstructing the ARN into individual referenceable components. And one of them is the account ID. So bear in mind that functions are often used for edge case scenarios. There's a lot of times where people have an edge case where they just need the account ID for whatever reason. I'm going to show you one in a moment. But functions are typically used in edge case scenarios whenever you're using them.
So that actually brings up a good question that somebody just brought up in the audience. What engendered the creation of the? So we've had the Terraform functions for a long time. What was the rationale behind creating the provider-defined functions? What made people think, oh, you know what, we need functions on the provider side now?
Yeah, good question. I can't speak for the product team, but from my experience, it is around these edge cases. There's a lot of awesome built-in functions into Terraform core, but they aren't, like I said, provider specific. There are points which I'm going to show you as well for the Google provider. I can show you right now, actually. The functions defined in the Google provider are these: location from ID, name from ID, project from ID, region from ID, region from zone, and zone from ID. Mm-hmm. A lot of different components you want to parse from an ID. I think a good example would be if you are creating a Cloud Run IAM binding on a existing Cloud Run surface, you need the location, you need the project, you need the surface, you need the role and the member. If you do not have the Cloud Run surface defined as a resource in Terraform, it's going to be very hard for you to reference the location, project name, role, and member, especially the location, project, and name, because that's what you typically refer to from the Cloud Run service resource. Now, if you only have the ID, you could use the functions to get that information just from the ID. So you can get location from ID, you can get project from ID, and you get the name from ID. So you don't have to hard code them 3 separate times. You don't have to hard code them 3 times. Hard code a location, hard code a name, hard code a project, where the Cloud Run service came from. So it is really for edge cases that are specific to a provider. Mm-hmm. But that's how it started. But there are way more cool things that you can do with provider-defined functions. I think another nice example is we have an awesome testing framework, and we have check blocks, we have validation blocks in Terraform for continuous validation. We have variable validation as well. But sometimes writing out a condition for validation can be a bit cumbersome if you have to. It can be a pain indeed. If you, for instance, have to say this variable, its input must be between 1 and 100. You have to reference the name of the variable twice. So I think I can write out an example. So we have variables at TF here. If I do variable and I do volume size, let me autocomplete that. I'll remove the default. I'll create a validation block. Number validation block. I'm a bit lazy. And then you do a condition where you say volume size, var.volume size. I can't type. Must be bigger than 0 or bigger than 1, and it must be smaller than 100. You have to reference and you need an error message as well, of course. And this should be condition. For some reason, my IntelliSense is tripping, but you have to reference the variable name twice. Which this is a very easy example, but they can become much more complex if you have to reference multiple patterns. So you could write a provider-defined function to simplify these conditions. So for instance, I started working on this Terraform provider called the assert provider, and the assert provider tries to simplify those variable validations by doing this. So here I have a variable, EBS volume size, and a validation block with a condition, provider assert between 1 and 100, and you specify the variable name just once. There's much more examples in here. For instance, if you want to do a check block with a data source, so you do a HTTP call to a different URL, terraform.io, and you're expecting an HTTP success, you can actually assert it. So you can do provider assert HTTP success. It's one of the functions that this assert provider exposes as well. So this can make these provider-defined functions. If you get a little bit creative, you can do a lot of cool things with them. The nice thing is that they always run as part of the plan, and they always run as part of the apply. They're supposed to be offline functions where you don't make any HTTP calls. and they're supposed to just transform data and return you a string, an object, a bool, or any type, including an object, for instance. So if you get a little bit creative with them, you can do a lot of cool things. Yeah.
And being offline, I see Terraform tests there, so you can use them also in your tests as well.
Yeah. So this is an example here for Terraform test where you define a run block and you do an assertion on the volume size during plan. But also you can also create a continuous validation block, for example, for check one, which is executed on every plan, every apply. So I think this assert provider could be very valuable for all these type of operations. And why I'm so excited about these provider-defined functions is that the value always comes after releasing, when a community takes a good look at it and they come up with all kinds of cool ideas. That's why I'm so excited for provider-defined functions, just to see what people are going to do with it. Yeah.
So sorry, so it doesn't make any API calls, is that correct? So it just uses what?
Yeah, correct. I'm going to show you guys how it's implemented as well under the hood in a moment. But all it does is you pass an argument into it. The argument get maps on a variable internally, and you do an operation on that, and you can return something. Yeah. So in this example here, we are doing an HTTP call with a data source. We're doing an HTTP call to Terraform.io, and we're getting back a response. And that response, the status code here, I'm putting into this assert HTTP success function. And we're evaluating if the status code is in the HTTP success range. Yeah.
Interesting.
Yeah. So, and this is just one example that I came up with. There's people who are much more creative than I am. So I think there's going to be a lot of cool use cases for this, for provider-defined functions in the future. Now, let me get rid of that validation, that variable block. So we talked about ARN parse, but there's also ARN build, which I think is going to be, this is then for still the AWS provider specific, which I think is going to be very useful when it comes to cross-account IAM policies, where you have to reference a different account ID. So an example here is if you want to allow another account to pull from one of your ECR repositories that you have in a specific account, usually what you have to do is you come up with a policy. So in this case, I call it allow cross-account pull. It's an allow policy, and I'm specifying a principal in here, which is the root user, because I want to grant every identity in this. This is just an example, right? I want to grant every identity in this account to be able to pull from my ECR repository. And you can use the ARN build function to construct an ARN. So what it does here is it actually comes up with an ARN, much like the ARN format, how you know it. I don't have an example here, but it basically adds the columns in here, and it then comes up with a string, and it puts it into this identifier block here. And all I do is I pass in a cross account ID from a variable, and I hard coded AWS IAM and root, and that way it comes up with the ARN for me. So that's an example of making your life easier when you're creating these cross-account IAM bindings.
That's awesome. This is definitely something that does make it easier. So as you're building these for yourself, is there going to be a feedback loop? How do other people leverage your provider-defined functions? So like you've built one, you love it, other people love it. How do they get to play with it?
Super good question. So if you create a provider, if you want to have people use your provider-defined functions, so I created this assert provider, for instance. Mm-hmm. Now it's on my GitHub profile, and if the provider is just on GitHub, people can't use it. Therefore, you need to publish it to the Terraform registry. This assert provider is actually uploaded to the registry, so you can download it, you can reference it in your Terraform configuration. So if people want to play around with provider-defined functions, I'll show you how to build one in a moment. But eventually, you will have to publish your provider to the registry. Good thing is that we have now going a little bit ahead of what I plan talking about, but we have a scaffolding framework that is going to help you publish your provider to the registry very easily. And that's also how I built my provider. So let me walk you through that actually. So how do you go about building these provider-defined functions? Well, we build providers using, well, here's HashiCorp's recommended way to develop new Terraform providers is in the Terraform plugin framework. It is the successor of the Terraform provider SDK v2. And the Terraform plugin framework, like it says, it's a very pluggable framework with different packages for different things, packages for each type. You have a package for logging. You have a package for there's a whole bunch of packages that make up this framework that allows you to write Terraform plugins. Bear in mind, when I say Terraform plugin, at the moment, the only plugin that is supported in Terraform is a provider. So it's interchangeable at the moment, plugin, provider. The framework is called Terraform Plugin Framework. And actually to help you, because it sounds pretty scary, right? Oh, you're going to have to build a Terraform provider. Where do I start? I just want to play around with the function. We actually have a scaffolder. Yeah, we have a scaffolder available, which is called the Terraform Plugin Framework Provider Scaffolding Framework, which is this one, Terraform Provider Scaffolding Framework.
Say that 5 times fast.
Terraform Provider Scaffolding.
No, don't.
No, I was just reading out what it says here. So Terraform Provider Scaffolding Terraform Plugin Framework. Right. And this is actually a GitHub template that you can use. So you can click Use this template. And what it does, it bootstraps. It provides a skeleton for you to build a Terraform provider, including CI/CD, including all of the practices that we have when it comes to, for example, adding when it, for instance, comes to Golang CI or Go Releaser, or adding a copyright header with the Mozilla public license headers to your file. So you can. I'll share or Chris might share a link with you. You can click on Use This. Awesome. You can click on Use This template, create a new repository, and then you can say, I'll create mine in my personal space, and I'll say Terraform-provider-HashiCorp, for instance. And I'm going to make it private. I'll do create repository, and then it takes a second to generate. And also bear in mind with the naming convention of Terraform providers, they have to be called Terraform provider HashiCorp. They have to be prefixed with Terraform-provider- and then the name of your provider. That way, whenever you publish it to the Terraform registry understands and comes up with a pretty name for your provider. It's able to parse it in a better way. That way, you nicely get the HashiCorp/AWS or B Schaatsbergen /assert provider whenever you want to reference it like this. Source B Schaatsbergen assert. So what is all in this HashiCorp scaffolded provider? You have an internal provider directory. So I think So if you want to go about building a function, the thing that is in the scaffolder that's most interested to whoever is building the provider is the example function.go. There are also examples for resources and data sources in there, but if you just want to build a provider that has a single function, I recommend you only look at that file, and that is this one. So you go into internal/provider, and in there, like I said, you have the resource, the data source, and the function. Let me get that, and let me zoom in a little bit. So there's a bunch of Go code. The scaffolders, like all the Terraform providers, are written in Go. That's because the framework, the Terraform plugin framework, is written in Go as well. So actually on our top here, we're saying function.function, and we're matching the example function simply to satisfy the implementation of the interface, of the function interface. And the function interface is forcing us to implement several methods, one of them being metadata, definition, run, and so it's 3: metadata, definition, and run. So what we do is we first come up with this function called new example function, and that returns a function. And this example function now it's an empty struct. It has nothing in there. And the reason why we do this new example function, it's like a factory method if you're a little bit known to programming. What we what we do is we simply return the instance of that function in order to register this function to our provider. So we create a function and we have to attach the function to our provider. And that is also an internal /provider and then provider.go. Because any resource, data source, or function that you create, we have to register it to the server, in this case, our provider. Mm-hmm. So if I scroll down a little bit, you will have resources, data sources, and functions. And in there, in functions, we're saying, give me that new example function. So we're calling that factory method. So let me go back to the example function. So yeah, that's a factory method. That's the struct that's associated with. Then we have metadata. Same for resource and data sources. Also for functions, there's a metadata function, and that is describing the friendly or name you're going to provide to the function. So how the function is going to be called. If the function would be called ARN build or local region from ID, that's the name you would give it here. So in my case, I had this assertifier, which has a HTTP success assertion function. I'll rename example to HTTP success here. Then you get the definition of the function. And the definition of the function is describing the schema. Again, everything in Terraform has every resource or data source or function has a schema. It's basically the interface to how you interact with that component. So in the schema, you define the things that go in there and the things that go out there that basically get returned. So here in this example, this is an example function from the scaffolding framework. We have a single parameter, which is a string parameter, and it has a name called input. And all we do is we return a string as well. So a string goes in and a string goes out. That's what this schema is saying. But you can imagine if you have an S3 bucket, a resource that also has a schema that has many more different parameters in here. The name, the region, whatever versioning is enabled or whatever. So that's what this schema does. It's the definition or it's basically the interface of that component. Then you have a run method. So what happens if that function gets called? We're going to run it. So on line 41, we're creating a data variable, which is a string, and we're mapping that to our only argument, which we get, which is this input argument, the string parameter. And if there's no error when we do the mapping, all we do is we return that string here. So this is a very simple example function. It echoes your given argument as a result. But you can imagine, for example, the assert provider, where we were talking about that HTTP success method. So let me show you the implementation of that. It is very similar. Again, we instantiate the function. We want to satisfy the interface. We come up with the factory method. We have a definition and a metadata. So here I called it HTTP success. We have a definition. An int64 param goes in there, which is the status code. It is also named status code. And then we have a run method, which is also very simple. Again, we do the mapping. And here we have one extra line of code that's basically saying is success status code. We pass in that status code, and we have a switch case that checks if this integer matches any of these HTTP status success statuses. If yes, we return it true. If false, if it's false, we return it false. So the implementation of functions can be very simple. Of course, you can make much more complex examples. It truly depends on what you're building. Yeah.
Nice. Mr. Doyle knows far more about Go than I do. We do have a couple of questions in the audience that I wanted to get to, but Sean, was there anything that you wanted to ask at the right now?
Not really about asking about Go or anything like that, but I can definitely see, when you first started talking about the parsing method, I could see this like potentially replacing some data calls, because I know when you get to complex Terraform, where you have multiple layers, like sometimes there can be like issues with data calls where it can't figure out things because it's trying to calculate something and it says, I forgot the exact error, but it's like can't calculate this before apply. And that's usually because there's some data call in there that's like, messing it up. So I can see like potentially with your parse function, the reason why my brain went there is because with the ARN thing, right? Normally it's a data call to get the current user account, and then you insert that data resource into the ARN. But here it's like you don't even need to do that. You could just use any ARN return from any resource and then parse that to extract out the account ID. So I'm wondering, like, if there's similar, I mean, what are your thoughts? Like, do you think there's going to be similar, like, things there where it's like, hey, I don't need this data resource anymore because I already have that information coming back in a resource object, and I can just like use a function locally to extract the information I need from that to build something else, right? Instead of making this.
Exactly.
It kind of seems like there was a workaround for a long time where it's like, hey, I need this piece of information. I'm not really building something, but I can go and fetch it.
Yeah.
So I can't like parse the resource that comes back.
Yeah, I think the example you gave about the error, and I'm assuming that's going to be the error which says, oh, this is an unknown value, and then it errors out because it doesn't know how many instances it's going to create, or there's still an unknown value somewhere, which is usually that data call that fetches the account ID or the current region or the username or whatever. So I do think for calls that we don't explicitly have to make to some API, but that we can rather solve locally. For example, constructing an ARN if we have all the given individual pieces, anyways. I think that's where provider-defined functions can really shine, and I think very much same for these things. It is expanding on top of the. So how I would like to see provider-defined functions being used is anything that expands upon the current built-in functions, but ones that are either provider specific for AWS, Google, or Kubernetes or Azure, or completely cool new things that people come up with, like this assert framework. There's already actually quite some functions being authored right now by folks. So I'm really excited to see what people are going to come up with. I've even seen stuff where they call functions from Go files and stuff like that. Of course, you don't want to get too messy with all possibilities. They have to serve a solid use case. But I think there's going to be a lot of cool things coming our way.
Yeah. And there's two interesting questions in the chat, Chris. I don't know if you want to ask them now.
Yeah. So the first one is from Kaylin, and the question is, are there plans? Hold on. Let me figure out how to do this. Yeah. Are there plans to separate out utility/function only providers from the others in the registry? Currently, it's kind of hard to find them.
Yeah, that's a super good question. As of now, a provider encapsulates resources, data sources, and functions. It is just that I created this, and other people created this provider-defined only function. And there are also, at the moment, utility providers that have a few functions. It's definitely something worth racing with the team. So I'm going to note it down. I don't have the answer, but I think we can get back to Kaylin on this. Yeah.
Cool. All right. And so the second question is from eSantics. Could we loop over a function result?
Could we loop over a function? Yes, you can. If it's returning a list, yes. Yeah. So say you are returning a list or a list of objects, you could loop over it. It's just going to produce any other type, like whether it's a bool or a list or a set or a map. You should be able to loop over that and do something with that data. Yeah.
Nice. Cool. Let me.
If that answers the
Sorry,
question.
did you mention, Bruno? So functions run during plan and apply.
Correct. Yeah. They are supposed to be offline functions that run during plan and apply. Yeah.
Do they run during a destroy as well? I guess you wouldn't really need to, but I'm just curious, like, does it run during a destroy?
That's a very good question. I've not tried that out. I don't catch myself destroying that often. It's something I'll have to. I barely ever destroy, to be honest. But that's a whole different question. I usually roll forward by removing the resources and then applying. But let me note that down and get back to you whether they are run as part of destroy.
Nice.
Okay. That's
Sorry, go ahead.
questions from the chat.
Yeah. I think we are good for questions right now. Some comments from Big Evil Beard, aka Stuart from AWS. A couple of other comments from Kaylin. and Mario comments from Mario, but no additional questions. So we're good.
Cool. So if you go back to, this is, I briefly showed you how you implement a function and how you register it with the provider, but we haven't talked about now publishing our provider. So if I go back to that scaffolding framework, what we now created is Terraform provider HashiCorps. Because apart from this internal provider, I'm not going to go too much into the details of how to build a provider, because that's a whole different topic. But I want you to be aware that if you want to play around with these functions and implement one yourself and publish it to the registry, there is a GitHub directory with several workflows that come with the scaffolder, test and a release.yaml. And all you have to do is make sure that you have a Terraform registry, that you're logged into the Terraform registry, that you have a GPG key to sign the release with. And if you publish a tag to your repo, this release file, this release GitHub action workflow is going to kick off, and it's going to build the release for you using Go Releaser, and you can then upload it to the Terraform registry, and then it is synced. So any other tag that you publish automatically gets fetched and figured out by the registry. So that's how you can play around with it. So apart from that, I think I covered most of the things around the provider-defined functions. I'm curious if you have any questions, Chris or Roger or John. Cool use cases.
Roger actually dropped a while ago. He had a work emergency that he had to go deal with.
Okay.
You know what? I'm good. So like I said before, my go is very un poquito. So my next journey after I've gotten the Terraform Pro certification is to start working on, building my own providers. But in order to do that, I've got to learn a little bit of Go first too. So my questions are more around like the process of building, which you are explaining. So now I've got that in my head. I now need to go find, something fun that I can build my own provider defined function for, and then go irritate ChatGPT to help me build it.
Nice. Cool. I'll be happy to help you, Chris. Maybe we can build one together.
I will definitely take you up on that.
Nice.
Mr. Doyle, what about you?
I guess so. I do a couple of questions pop in my head, but I'll just ask one. So and maybe you already answered this again. I just apologize. It's getting coffee in me. So functions can be used, they're used anywhere, right? They can be used in outputs, they can be used in variables, they can be used as input parameters to resources or data sources. They can basically be used as just, anywhere, right? Is that correct?
Yes, that is correct, apart from the init, as far as I know. Yeah. I don't know, so I'm unsure whether they run during the init, and I'm unsure whether they run during destroy. I haven't had a use case or a function that I could implement as part of the init or the destroy to test that out. So I'll have to figure that out and get back to you. But yes, they run as part of the plan and as part of the apply, as far as I know. And you can reference them anywhere where you can reference any other value. So you can put them in an output block, like you said, variable validation, assign it. If you want to assign a value to an argument of a resource or whatever. Yeah.
Great. I think Kaylin has another question. Are there plans on function validation and protection for the end user?
Oh, as in, I'm curious what function validation is referring to. Could you elaborate a little bit for me? That would be, in the comments, that would be very helpful.
Yeah, we'll let him, he's a slow typer, so it'll take him a second to get that out. So we'll continue on while he's typing that out.
Sure. And good to know that on the registry, if you ever want to use an existing provider-defined function, for example, in the Google provider, we have this function section. In there, we have the functions. If you click on one, you have an example usage. Apart from that, you have the signature as well, so you know how to call the function. In this case, for example, region from ID, here it says you give an ID, which is a string, and the return value is right after the closing parentheses, which is a string as well. So I think if you ever want to play around with existing functions, make sure to take a good look at the documentation. That should help you. Yeah.
So actually, could you scroll down a bit? to the signature, just because I haven't looked at this before? Okay, so it's got the function signature, the input, and then the output, and then you have the argument there. Okay. Yeah, I guess perhaps maybe that's what Kalen was, questioning, because I had the same thought, like, how do I know region from zone if I give it a zone? Like, what is it going to give me back, right? It doesn't seem clear from here. It gives me back a string, but what's the output? Like, what does that string format look like? Like, what if that's not what I'm expecting, right? Or what if it's gives me a, I don't know, a VPC ID or something, right? Something completely different. I mean, in that case scenario, you probably have to go look at the source code, I guess, because there's not a way to see that on this registry page yet. But is there?
Yeah, so that's a super good question, but that eventually comes down to what the provider maintainers are implementing under the hood, because the registry can look at the source codes and figure that out, much like Terraform Core can figure that out for you on the fly. So we do have, I think the team developing the plugin framework has added some very nice things. So if you go to your internal provider and you go to the example function, you get the name here and you get the markdown description. So maybe it's good that I'm going to cover this as well. There's actually more things that you can specify to the string parameter, but one is the type is known here, the name is known here, and the description is known here. For the registry documentation, so I guess one way people that implement a provider-defined function or provider maintainers, they should be aware that we have the TF plugin docs generation tool, which is this thingy here. Oh, that's the wrong one. TF plugin docs. I'm sure I'll find it. Yes. So there's a generator for plugin and provider documentation. It actually reads through the source code and generates documentation for you. So if I go back so it's called Terraform plugin docs. So I think Chris can maybe share the link with you. But if you go back to the assert provider, if I go into one of these functions, for instance, contains, here I have several things. So I have a list parameter, allow null, allow unknown values, description, name, and element type. And what I do, the scaffolding framework does this for me, actually. There's a tools directory that you get. And inside tools, there's this tools.go. And in there, we have the TF plugin docs imported. And we have a go generate command. So I also have a make file with make generate. And if you either you can simplify it to make generate, or you can do go generate and then point to the directory. But what go generate is going to do for me is going to call the TF plugin docs and is generating all this documentation for me. So to get back at your question, it's a combination of a clear and well-defined interface combined with clear and concise documentation on how to use it. And this is where a maintainer of a provider or anyone building these provider-defined functions have to just pay attention to. Because returning a string almost says nothing. So what I try to do in my documentation is I show the argument, including the type. So the signature is also auto-generated, but I try to be a little bit more specific in the argument and the return type. So if I would go to the documentation of the assert provider on the registry, let me show you, and we go, for example, to HTTP status code success or server error, I'll have the signature here, HTTP server error status code number, and it returns a bool. But what is it actually returning? The return type of, I try to specify that here.
Right. And I think for Boolean types, it's going to be pretty straightforward. But if it's, a complex type like a map or something, it'd be, it seems like right now, so it seems like you could have like a return type section and then give an example. I think I saw on the AWS function that it had the example actually up in the example usage.
Here indeed. Yeah.
So but they could actually put like a return type and then have that example down there, right? It's just not really standardized yet. It's just kind of up to the provider writer. Okay.
Exactly. I'm sure at some point there's going to be this provider-wide standard on how people structure their documentation. It just takes a little while before people to adopt it and come up with nice nice ways to document it. So I'm expecting that people will do something like what I just showed you, with something like the return type here, and they'll try to specify a complex type or break down a complex type in a documentation there. Yeah.
Right.
So Kalen did come back and qualify his previous question. The question of, are there plans on function validation to protect the end user? His scenario is a bad actor creates a provider-defined function that is able to exfiltrate data, and somebody else uses it, and now that bad actor is scraping data.
Yeah, that's a super good question. The same question, so I wouldn't specifically target functions, but so the same could happen for a resource. If you create a resource, you can make any other arbitrary Go call in there as well to do whatever. So this is a broader problem, and I would say this almost goes for any software that's out there. I would not know from the top of my head how we could go about protecting weird, arbitrary, vulnerable calls in a resource, data source, or a function. That really depends on what someone implements.
Yeah.
I guess that source code is available and that people collaborate on this out in the open is already very helpful. But I think that's about it. Yeah.
Yeah. No, that's fair enough. I mean, that's fair. it's a fair response.
I just thought of one other question, and I don't know, Bruno, if you know this, but does it work in the console, like Terraform console on the CLI, like if you're trying to test something?
Oh, that's a very good question. I would have to try that out as well, actually. If you can call them from the function, from the console. You mean if you write Terraform console and you get this interactive terminal, right?
Right. Yeah, like the local REPL. Like if I just want to try to parse ARN, but I just want to try it out in the console first. Like,
okay, let me test that out as well, and then get back to you on that. I don't know, to be honest, whether providers are supported in that console, in that REPL. I'll have to test that out for you, and need some time to take a good look at that. Yeah.
That'd be interesting. Yeah, if it's imported into there, so because I could see that as being a way to say, like, is this doing what I expect, right?
Yeah, yeah, and this is a cool thing about it. Like, during this 40 minutes we talked, or 50 minutes we talked, there's already like 5 new things that we can try out. That's what I love about, 1, provider-defined functions, and 2, that this is so new and people are coming up with all these cool ideas. I made a couple notes meanwhile, so let me get back to you on that.
Now we can go talk to the product team and get some new stuff put in there. Awesome.
The DevX team. Yeah.
Cool. All right. I think we're dried up on questions for now. What else?
Yeah, maybe be aware that we have developer.hashicorp.com documentation around plugin development, specifically for the Terraform plugin framework. And there's this functions overview section, which covers the concept, the implementation, testing, and documenting it. This is very helpful if you want to write a function and see what all the possibilities are. I think Chris can share this as well in the chat.
It's sharing right now. Yep.
Nice. And I would recommend we have a blog post, which is this one, Terraform 1.8. We authored this blog post called Terraform 1.8 Provider Functions for AWS, Google Cloud, and Kubernetes. So on launch day of Terraform Core 1.8, we also launched the support for provider-defined functions in AWS, Google Cloud, and Kubernetes. So be sure to test them out, and I would say play around with it. Yeah. And
there is the link for that article as well. Awesome.
Yeah. Nice.
Cool. Well, Bruno, thank you so much for coming on the show. Loved having you on. This is very informative. I've got a lot. We have got a lot of homework to get into to play with this. We are dried up on questions from the live studio audience, so I think we're good. I think we got it.
Well, thanks for having me. Appreciate it.
Yeah, absolutely. So let me remove that. Then there's just the 3 of us because we lost Roger down. Awesome, folks. Well, we will see you again next week. Thanks very much, and we'll talk to you again soon. Have a good one.
Cool. Bye, everyone.